Hi guys, so I want to first start talking about linear graphs. This is what you guys learned the majority of last year. They are straight line graphs. And this unit, we are talking about quadratic graphs. So linear are when you only have x to the power of 1. Quadratic is when you have x to the power of 2. And what it does is it turns your graph into this U shape. So we're going to be talking about quadratics, and we're going to be talking about the different ways that you can write quadratic graphs. The first form is called standard form. So it looks like this. A quadratic graph will always make a shape of a U. And then you have your standard form, which is y equals ax squared plus bx plus c. A, B, C, all of those are numbers. Our other form is our vertex form. So we got standard form and vertex form. You write vertex form as y equals a parentheses x minus h squared plus k. And you guys might notice that this looks familiar because it is very similar to absolute value graphs, which we talked about previously. So first, let's take a look at standard form and what information we can get from standard form. So our axis of symmetry is always going to be negative b divided by 2a. And what is your axis of symmetry? Let's draw us a sketch of a parabola. This is your vertex. Your axis of symmetry is the line that splits your parabola in half. It's called the axis of symmetry because they are symmetrical. That means the distance here is the same as your distance here. So right down the middle. For your vertex, you have an x-coordinate point, and in order to find your y value, you take your x from your axis of symmetry and you plug that into your equation. If your parabola opens up, that means a is greater than 0. So this number is going to be greater than 0 when it opens up. So opens up means like that. If a is less than 0, that means it will open down, like a little sad face. Your vertex is a blank when the parabola opens up. So if we look here, our vertex is down at the bottom, so that is a minimum. And then a blank when the parabola opens down. So your vertex would be up here at the top, which means that would be a maximum. So you can think about it like a hill and a ditch. Minimum means you're in a ditch. The maximum means you're at top of the hill. When you're looking for your Y-intercept for standard form, it's always going to be 0, c. That's because this cancels out with 0. This cancels out with 0. The only thing that you're left with is c. So if you're looking for the Y-intercept, it's really easy when it's in standard form. You just take your constant at the end. A couple more things. Your parabola is narrower or skinnier than your parent graph if the absolute value is greater than 1, and it is wider or fatter if your absolute value is less than 1. And your slope, which is your a value, will find points of the parabola that are 1 unit to the right and 1 unit to the left. So if we're looking at a, if there is a 1 there, then that means we have a slope of 1. Rise 1, run 1. If the a is a 2, then we can do rise 2, run 1. You'll see examples of this. So here's just information that could be helpful when you have standard form. As a reminder, if you're trying to find your axis of symmetry, it is x equals negative b divided by 2a. If you want your vertex, then you would take your x from here, and then substitute in that number for the rest of your equation. So let's say your x was 2, you would put 2 here and then substitute in 2 to find your y. And then lastly, your y-intercept is always 0, c. So that one's real easy. Okay, so let's try. So first thing, they want us to label A, B, and C. Again, these are the numbers in front. So A is 2, B is -8, and C is 6. So it says, okay, is this parabola going to open up or down? So if my A is positive, it will open up. If my A is negative, it will open down. What do you guys think is going to happen for this parabola? Well, A is positive, so that means it's going to open up. Okay. Next, we're going to find our axis of symmetry. So it's the line that cuts it in half. So negative B over 2A. What is my B? My B is -8. 2 times, what is my A? My A is 2. Now I can simplify. A negative times a negative is a positive. 2 times 2 is 4. So my axis of symmetry is a line that goes through 2. So I can draw that on my graph. It's going to go straight down 2. Da, 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 da. Here we go. Here we go. Okay. So this line is our axis of symmetry. Some people call this like AOS, axis of symmetry. Now this can help us find our vertex, because if we remember, if our graph is going up or down, the vertex is always in the middle and it's always going through our axis of symmetry. So let's figure this out. I'm going to do the work on the side. The equation is y equals 2x squared minus 8x plus 6. What number are we going to use for x? We're going to use 2, because that is our axis of symmetry. So we're going to substitute it in. Okay, I want you guys to go ahead and simplify this. What do you get when you simplify it? Okay, let's check your answer. 2 times 2 is 4. 8 times 2 is 16. This is 8. These would make -10. And then 8 minus 10, -2. So now I have my y value for my vertex. So my vertex is x of 2 and y of -2. So if I go on my graph, 2, -2, I put a point here. This is my vertex. And we said it's going to open up. So is this going to be a minimum or a maximum? Is my vertex a minimum or a maximum? It would be a minimum, because if it's going to open up and it's going to be down here, it's going to be in the ditch. Okay. So next they want us to put a point for our y-intercept. Okay, so we know it's just 0, c. What is my value for c? 6. Easy peasy. So we go 0, 6. I'm going to tell you something that's super cool. The nice thing about parabolas is once you have your axis of symmetry, once you know one point, you can draw the other point on the opposite side. So we have 6, which is 2 spots away from the axis of symmetry. So that means there's going to be another point 2 spots away. So 1, 2. They are equal distance from the axis of symmetry. And then we're going to do one last point with our slope. So A was 2. We're going to use this as a slope, and that would be 2 over 1, our rise and our run. So from our vertex, we're going to rise 2 and run 1. So up here, rise 2, 1, 2, and run 1. And again, because it is a parabola, we have our axis of symmetry, we can draw a point on the other side to match it. So this is 1 box away, so we can draw another one 1 box away. And we got plenty of points here now. We're just going to connect it. Remember, you want to try to make it as close to a U as possible. It doesn't have to be perfect, but just do your best. Whoops. Whoops. Let's try that one again. Okay, good enough. And we draw our arrows because parabolas go on forever, unless we have boundaries. But yes, does it look like a U? It's a little sloppy, but it's okay. So now let's try one where you guys try more. So our equation is y equals negative 1/2 x squared plus 3. What is my a value? What is my b value? What is my c value? Okay, so a is in front of x squared, so we have a negative 1/2. B is in front of x. However, I don't see an x, so that means it's actually 0. And then c is my constant, which is 3. Okay, is this going to open up or down? We have to look at A to determine if it's going to open up or down. So what do you think? Is it going to open up or down? A is negative, so it is going to open down. Now we have to do our axis of symmetry, which is that equation, negative b divided by 2a. Okay, so what did you get for the axis of symmetry? Once you plug your numbers in, what did you get? Okay, let's take a look. We got negative 0, 2, and negative 1/2. If I have $0 and I divide that between negative 1 people, how much did everyone get? They got just 0. So you should have gotten 0 for your axis of symmetry. So we can draw this right down the middle. And I actually like it when it's 0 because it makes substituting so much easier. So we're just going to plug in 0 for our vertex. So for our vertex, we know x is 0. What did you get for your y? Okay, let's plug it in up here. We got negative 1/2 times 0 plus 3. Well, negative 1/2 times 0 is just 0. And 0 plus 3 is just 3. Ooh, and this is actually the same as our y-intercept because it's just 0 comma c. And our c was 3. Okay, let's put our vertex on our graph. 0 up 3. We said it's going to open down, so it's going to be going down. And then is this vertex a minimum or a maximum? If it is opening down, what do you guys think? It's going to look like this. Is that a minimum or a maximum? It would be at the very top, so that would be a maximum. Okay, and we can get one more point from our A. It'll act as a slope. That's what it says in this corner over here. You can use A to help you find your point. So A is equal to negative 1 over 2. This is going to be our rise and our run. So starting from our vertex, we're going to go down 1 to the right 2. And again, we can mirror it. So this is 2 boxes away. So on the other side, we can do 2 boxes away. And then we can kind of just sketch it and say it's going to go down and it's going to go down. All right, that's a pretty good sketch. Okay, so that is standard form. We can find our axis of symmetry, we can find our vertex, we can find if it's a minimum or a maximum, and the y-intercept. Now let's take a look at our second option. So our second option for a parabola is called vertex form. And mathematicians aren't super clever, so they called it vertex form because you can easily find your vertex from this equation. So your vertex we often refer to as your h and your k. And if you look, we have an h and we have a k. So our vertex is our h and our k. And then our axis of symmetry is your x value or your h. So x equals h. So it's a straight line going up and down, and it'll be x equals h. So for our last equation, it was really easy to find the y-intercept. We just used our c. For vertex form, it's a little bit more work. So you would take your x value as 0 because we know it's going to be on the y-intercept. And we would plug this into our equation and we would figure out the y. So whatever f of 0 is, that would be your y value. So let's take a look at what that would look like. Okay, so for my axis of symmetry, we would say x is equal to my h. So we got my h and my k. If you notice in the original equation, it says x minus h. So that means we're going to have to change the value of this 2. It's not going to be a positive 2, it's actually going to be a negative 2. So my x is negative 2, and then for my vertex, we use negative 2, which is my h, and then my k is 3. And then I'm going to scroll down so we can add this to our graph. Okay, so my axis of symmetry goes through negative 2. Straight up and down through negative 2. And then our vertex is negative 2, comma 3. So we're going to put it on this point right here. Do you guys think it is going to open up or down? Our graph is going to open down. So we're going to use our a, which is negative 2, to help us find some other points. So a is negative 2. If we write that as a fraction, that's negative 2 over 1. This would be my rise, and this would be my run. So we start from our vertex, and we go down 2 boxes and to the right 1 box. And we can put a point there. And again, we can use the idea of symmetry to put it on the other side as well. And then we can get one more point from our y-intercept. Okay, so the 2 points that we added were negative 1 and 1. So negative 1 and 1, and negative 3 and 1. Okay, so now we're going to try to do the y-intercept. So we're going to make it 0, and I'm going to do my work over to the side right here. So we got y equals negative 2 parentheses 0 plus 2 squared plus 3. Okay. Okay, what did you guys get if you finish this? What do you get for your y-intercept? Let's find out if you were right. So we get a y-intercept of, oh, this is negative right here. So this should be negative 5. A y-intercept of negative 5. So we'll put a point here. Again, we can put one on the other side as well. And then we can try to sketch it as good as possible. Add our arrows on the end. And that one is all done. Okay, let's try another one. Okay, our axis of symmetry for part B is x equals h. What is our h in this equation? Our h is 4. So we would put 4. All right, our axis of symmetry is 4. So we can come to our graph and we can draw a line straight up and down through 4. So this means it's going to cut our graph down the middle. Now they want us to find our vertex. What is our vertex? What is our h and k? We have 4 as our h, and we have -3 as our k. So 4, comma, -3. That is our vertex. Do you guys think this is going to open up or down based off of our a? Our a is positive, so this will open up. Okay, and then now we're going to use our a as our slope. So our a here is 1/2. And we're going to use this as our rise and our run. Okay, so starting at our vertex, we're going to go up 1 box and to the right 2 boxes. So up 1 box, to the right 2 boxes. Where am I going to put my other point that mirrors this one? What is the coordinates of the other point? It would be 2, comma, -2. As it is on the exact other side of the axis of symmetry. Okay, so we got 6, -2. And then we got 2, -2. And we could just sketch it based off of that one, but let's try our y-intercept. So we can substitute this in for 0. Let's make this 0. Okay. Y equals 1/2. Our x is going to become 0. Okay. Go ahead and take a second and solve. What do you get? Oops. 16, half of 16 is 8. -3 would be 5. Okay, so you should have gotten 5 for your y-intercept, 0, 5. So 0, 5. Again, we can draw a point on the other side. So we just look on the other side of the axis. This was 1, 2, 3, 4 spots away. 1, 2, 3, 4 spots away. Okay, and now we can draw our U, our parabola, and yay, it's all done. Okay, now for our last idea of the day, we are going to look at how we can go from vertex form into standard form. Let's say we have our vertex and we want to be able to change it into standard form because we want like the y-intercept or something. So if we read this, y equals 2 times x plus 1 squared. If we remember squared, that means it's being multiplied by itself. So we put y equals 2, and then x plus 1, that's being repeated twice, x plus 1. And then you guys know how to do the distributive property. You do 2 times x, and then you do 2 times 1. So that would give you 2x plus 2. However, you guys have not seen how to multiply. These are called binomials because there's 2 terms. So it's like 2 terms and 2 terms. How do I do the distributive property there? Well, there's actually this method called FOIL method, and we have the box method. It's basically showing you how to multiply. So let's take a look at what that is. So the FOIL method is saying like you're doing the distributive property, but you're doing it for the first term and you're doing it for the second term. So the distributive property would say, okay, take your number, multiply it by the first one, and multiply it by the second one. That's the distributive property. But when you're doing the FOIL method, you also have to do that for the second term. So you have to take your second term, multiply it by the first one, and then multiply it by the second one. They call it the FOIL method because they say do the first numbers, do the outside numbers, then do the inside numbers, and do the last numbers. Honestly, I don't remember it by saying first, outside, inside, last. I literally just draw the arrows. So like if I were going to try this one, I would just draw my arrows. I would say, okay, I need to multiply those two and those two, and then I need to multiply those two and those two. That's how you do the FOIL method. Sometimes people forget to multiply everything. So in education, we've slowly moved towards the box method. But what's the box method? Let me show you. I know you guys are so curious. So it's the same thing, but instead we draw a box. So draw your box, and then you take your first parentheses and you put it up top. And then you take your second parentheses and you put them on the side. And then you just multiply. So 4 times 2 is 8. X times x is x squared. And then you do 4x times negative 3, which would give you negative 12x. Then you would do negative 5 times 2x, which would be negative 10x. And then you would do negative 3 times negative 5, which would give you positive 15. You're doing the same thing, but instead you're organizing it in this box. My recommendation, do it in the box method because you're going to have to learn how to factor. And how do you factor? Basically using the box method. So trust me, you'll save time if you just learn how to multiply it this way. If you want to do FOIL, that's fine. It'll be the same thing. And then once you have everything in your box, you can just write them all out. So this is your answers. You got your AX, you got your 10, you got your 12, and you got your 15. You just bring it all down. And then normally we would combine these numbers. So we would combine these ones because they're like terms. Okay, it looks a little funny, but we have 2x plus 2. So that's going to go on the top of my box. So we got 2x is my first term, and my positive 2 is my second term. Okay, in my second set of parentheses, we got x plus 1. So x is my first term, and 1 is my second term. And now we can just multiply. 2x times x is 2x squared. 2 times x is 2x. 2x times 1 is 2x. And then lastly, 2 and 1 make 2. So now we can write all of these terms right below it. Everything inside our box we'll write down. So we got 2x squared plus 2x plus 2x plus 2. And then these are like terms, so we can put them together. So my final simplified answer in standard form would be this. So what did we do? We just took our equation that was in vertex form and we turned it into standard form. So now that you've seen me do it, I'm going to have you try it. So first we want to write this in expanded form. Y equals -1 x minus 3 times x minus 3 plus 4. So the first thing we're going to have you multiply is -1 times x minus 3. What do you get when you multiply -1 times x minus 3? Use the distributive property. Okay. We would get -1 times x, which is -1x, and we would do -1 times -3. Okay, now we have x minus 3. Okay, so this is where we're going to do our box method. What goes on the top? Our first term, which is -1x and 3. Okay, what goes on the side of our box? Our second binomial, which is x and -3. Make sure you keep the negative with the 3. What do you get when you multiply -1x and x? -1x squared. What do you get when you multiply 3 and x? 3x. What do you get when you multiply -1x and -3? +3x. And then what do you get when you multiply 3 times -3? +9. Okay, let's write all of those down at the bottom. So inside our box, we have -1x squared plus 3x plus 3x plus 9. What numbers can I combine because they are like terms? I can combine my 3x's. So that would turn into 3 plus 3 is 6. And we are almost done. However, if I scroll back up, over here, we had a plus 4. So we want to make sure we don't forget about this plus 4. So if I scroll down, we're going to put plus 4. And we can combine these. And what do you get as your final answer? Ta-da! Now we turned that one from vertex form into standard form. So now what you're going to do, you are going to work on some delta math problems that are going to ask you to identify parts of your parabola. And then on Wednesday, we will talk about more how to do box method. All right, have a good day. Bye.